For decades, the global aerospace market operated on a predictable, hyper-competitive loop. As soon as one manufacturer launched a breakthrough jet, its rival immediately poured billions into a clean-sheet response to leapfrog them. But right now, at the world's most critical aviation boardrooms, that loop has been abruptly shattered. Airbus and Boeing have officially confirmed a historic, multi-billion-dollar standstill. There will be no brand new, clean-sheet, narrow-body passenger jets entering commercial service for at least the next 10 years. The next generation of aviation is officially frozen until the late 2030s. This unprecedented admission unfolded on the industrial stage of global air shows. Airbus Chief Executive Officer Guillaume Faury explicitly confirmed that while technical preparations for their next-generation single-aisle platform are underway, a commercial entry into service date before the late 2030s is an absolute impossibility. Simultaneously, Boeing's leadership mirrored this exact timeline, stating that the company requires the next several years just to stabilize its internal operations before it can even think about funding a clean-sheet design. For a global industry driven by rapid technological acceleration, this 10-year freeze represents a massive structural gridlock. To understand why the world's two largest aerospace monopolies are willingly pausing their technology race, we have to look past the marketing brochures and dissect the brutal macroeconomics of their factory floors. Airbus and Boeing are not freezing development because they lack engineering talent. They are freezing it because they are utterly trapped by their own success. They are holding a staggering, collective 10-year backlog of unfulfilled aircraft orders. Introducing a brand new airplane design right now would not increase corporate profits. It would completely collapse their current cash cow assembly lines. Today, we are opening the industrial spreadsheets to expose the hidden mechanics behind the great aerospace freeze. How does a combined backlog of over 15,000 aircraft completely paralyze the innovation pipeline of the West? How are severe sub-tier supply chain collapses dictating the speed of aircraft design? And why are global network airlines being forced to fly decades-old technology for the foreseeable future? The single biggest obstacle to building a brand new airplane is the sheer volume of planes that are already bought but unbuilt. Airbus and Boeing are currently sitting on an unprecedented global delivery queue surpassing 15,000 active orders. For context, if both manufacturers ran their assembly lines at peak capacity without a single supply chain hiccup, it would take them until the mid-2030s just to clear the requests currently sitting on their order books. This creates a massive industrial phenomenon known as the backlog paradox. In aerospace economics, designing a clean-sheet airliner requires a capital investment frequently exceeding $15 billion, followed by an extra decade of safety validation flights. If Airbus or Boeing announced a brand new, ultra-efficient narrow-body jet today, airlines would instantly try to cancel their existing orders for 737 MAXs and a 321 NEOs to wait for the superior model. This would trigger an immediate multi-billion-dollar wave of capital cancellations, dry up the current cash flow derived from active handovers, and leave manufacturers holding billions in obsolete factory infrastructure. Innovation, quite literally, becomes financially toxic. Even if both aerospace giants were willing to risk cannibalizing their current cash cow models, they face a secondary physical barrier: the absolute collapse of the sub-tier aerospace supply chain. The public typically views commercial aviation through the lens of a simple duopoly: Airbus versus Boeing. But beneath these prime contractors sits a vast, fragile pyramid of thousands of highly specialized sub-tier suppliers, foundries, and raw material processors that forge everything from titanium landing gear components to microscopic engine valves. The sub-tier supply chain is operating at its absolute breaking point. Decades of consolidation, combined with ongoing industrial labor shortages, have left foundational component manufacturers completely unable to scale throughput. Prime manufacturers can barely source enough specialized castings, aerospace-grade forgings, and precision engine valves to maintain current single-aisle assembly tempos. If an engineer wanted to introduce a radically new airframe design, requiring entirely new manufacturing tooling, custom sub-tier metallurgy, and advanced carbon fiber composites, the supply chain would completely freeze. The industrial foundation of the West is simply incapable of manufacturing a clean-sheet airliner right now. There is also a strict technological metric that dictates when a new airplane is allowed to exist. In commercial airline operations, a brand new airframe must deliver a minimum 20% reduction in fuel burn and operating costs compared to the jet it is replacing, to justify the immense capital risk of its development. Right now, traditional turbofan propulsion technology has hit an engineering plateau. Subtle adjustments to fan diameters and engine core temperatures are only yielding tiny, incremental, single-digit efficiency gains. To cross that critical 20% disruption threshold, engine manufacturers are having to explore radical, unproven propulsion concepts like CFM International's open rotor architecture, which completely eliminates the traditional engine nacelle casing. However, open rotor engineering introduces intense new aerodynamic profiles, complex acoustic sound signatures, and strict regulatory safety hurdles that require years of computational mapping and active flight validation. Until these advanced propulsion systems and alternative hybrid electric configurations are fully matured, certified, and industrially scalable, building a new airframe is completely pointless. The consequence of this 10-year industrial freeze will be felt directly by the traveling public. Because next-generation narrowbody designs are completely locked in a holding pattern until the late 2030s, commercial airlines are being forced to aggressively extend the lifespans of their current fleets. Aircraft that were scheduled for retirement are instead being sent back into heavy maintenance hangars for expensive structural overhauls and engine rebuilds to squeeze extra years out of their aluminum frames. This reliance on aging infrastructure means global flight capacity will remain highly constrained, operational maintenance overheads will climb, and passenger ticket prices will continue to absorb the cost of a bottlenecked sky. The aviation industry isn't waiting for a new design to change the world. They are simply praying that the fragile industrial infrastructure keeping the current sky alive doesn't break before the next generation is finally unfrozen.